A bipolar junction transistor, BJT, is a current-controlled active device in which a small base current regulates a much larger collector current. It is formed by two PN junctions arranged as either NPN or PNP, and its operation depends on the injection and movement of charge carriers. At a fundamental level, when the base emitter junction is forward biased, charge carriers are injected from the emitter into the base. Since the base region is very thin and lightly doped, most of these carriers do not recombine and are instead swept into the collector. The electric field of the reverse-biased collector base junction results in a large collector current controlled by a much smaller base current. The relationship between currents is defined by current gain, where a small change in base current produces a proportional and larger change in collector current. This makes the BJT effective for amplification. However, its behavior is strongly dependent on biasing, which determines the region of operation. In the cutoff region, the transistor is off. In the active region, it provides amplification, and in saturation, it behaves like a closed switch. In analog circuits, BJTs are used for linear amplification, where signal variations at the input are reproduced with greater amplitude at the output. In digital circuits, they operate as switches, transitioning between cutoff and saturation to represent logic states. The performance of a BJT is influenced by factors such as temperature, carrier recombination, and junction properties, which affect stability and gain. Despite the dominance of field effect devices in modern circuits, BJTs are still widely used in applications requiring high gain and precise analog performance.